test presently, taking a look at this particular problem about approximating the real zeros of a function based off of a table is how we had done this. So the first thing I did, on our test, we'll have the tables kind of pre-generated. I made them in Excel, but for sake of time now, I generated a quick little table here for us using TI-84. So, based off of this table, where does an x-intercept occur? At 0?
Oh, no. 3.
Around 3, right? Because there's a sign change right here from negative to, well, I guess that's not even positive. But in this case, better yet, we actually know it happens exactly at 3 because it's equal to 0. All right, but anytime there's a sign change, I know that an x-intercept occurred between those 2 points. So, so x-in occurred at x equals 3, I guess. Yeah, because this one happened to pass at a perfect point. Let me actually zoom in here. Let's see if I go to table set, and bless you, let's start counting at 2, and we'll count by tenths, and go to table. So you can see, let's see, so we're getting closer and closer to 0, and yeah, right there we can definitely tell that, yeah, there's a sign change from negative to positive, and better than that, we actually know where the 0 occurred, right? So we know that's 3.0 for sure, right? Now let me just extend the question slightly. Oh, I did end up opening up that. Oh well. What if I want to find an x-intercept? Not an x-intercept, but a min or a max. So let me go back to the table set and count by, oh man, my screen is glitching. Let's see. I'll start counting at negative 3 again and count by, I don't know, maybe like 0.25. No, that's the graph. I don't want to cheat. No cheating. Good plan. All right, so looking at this, how can I tell where a min or max occurs? Can you remember?
When like the numbers get higher and higher and they keep getting fall.
Yeah, so exactly. So it has to do with the direction change of the y value. So let's see. So looking at this negative 18, it goes from negative 18 to negative 13 to negative 9 to negative 6 to negative 5 to negative 3. So these are all increasing here, right? Would you guys agree? Right? Negative 3.8, negative 3.3, negative 3.0. I think there's a sign change right there. So based off of that, yeah, so check this out. So it is going up, 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 and then it drops back down to negative 3.4, right? So if it was going up and then down, is that a min or a max? It's a max value, right? Like we were going uphill and then downhill. So here I could say that a max value occurs somewhere between negative 1.75 is less than x is less than negative 1.25, something like that. Right? So based off of that sign change, I was able to determine that. Let's keep going for a little bit. I got the blurries. Here we go. Enhance. Focus. Let's see, I'm going to start scrolling down. Let's see. So from that point, actually, oh, then it starts getting more negative, 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 More negative. More negative. It's slowing down though, I feel. I think it's got a turnaround coming here, I'm guessing. And oh, I think we found it. Yep, there's a turnaround there. Oh, let's see. Hopefully I didn't grab a screenshot right during that VSync glitch. I did not. So, so lo and behold, let's look at our sign changes. So it's going down, 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 and then up, right? Because 14.14 in the negative is less negative than 14.63 in the negative, right? So I'm saying that there was a sign change somewhere between here, right? It went down and then up, so that would be a minimum value occurring between 1.25 is less than x is less than 1.75, right? Something like that. So mins and maxes are based off of your analysis of the change in direction, not the change in sign. And just so that we can see what's going on, let me hit graph here. And, well, you can see there's our local max occurring, what was that, around negative 1.5. And then there's a local min, looks like it occurs down there. I won't bother fixing the window because it's just a quick example. Right, somewhere around where we just set. So, and then it looks like it goes off infinitely in that direction and it goes infinitely down in this direction. I knew that there was only 2 bends at most for this because it was a third-degree function. Right. Okay, maybe one more quick question to review. How can I help you? What can I do for you? And sure. Let's see, I think those were hiding on the back. Is there a preference maybe from these? Oh, inverse functions right down here. I don't know, 56 looks a little bit interesting. I guess I'll just grab a snapshot of that. Yeah, and then we'll call it after this. Let's see. So find the inverse of this function is our objective. So obviously you didn't necessarily have to do this last night, but that's quite all right. So step 1 would be replace f of x with y. That's already done. Step 2, switch the x and the y. So x equals parentheses 2y plus 3 all squared. Next step is solve for our new y. So what would I do to get this y by itself? It's got 3 operations taking place on it. Yeah, I have to square root that. Like diffusing a bomb, I have to do it in the right order here. I assume that's a thing with bombs, maybe. I don't know. But yeah, this square is the one that's kind of the outermost thing that I have to deal with. So I will get plus or minus the square root of x is equal to 2y plus 3. And now what do I do? Yep. And this will be outside of the square root. So I'll have plus or minus the square root of x minus 3, not under the radical, is equal to 2y. And now what do I do? Yeah, divide by 2. So it's up to you if you want to divide each term by 2. That's fine. Or you can divide this whole side by 2. Those are both mathematically equivalent. So I end up with y equals plus or minus the square root of x minus 3 all over 2. And then last step, you can write that as, they actually wrote their answer as y to the negative 1, so like y inverse. I'll write it as f of x, or f inverse of x. Right, same difference, plus or minus the square root of x minus 3 all over 2. And I suspect that this inverse will not be a function. That's what I was going to say. So, so there's 2 quick problems for you. So hopefully we are ready for this test. I'm going to end this video.